Hi, we are SolarUp, and we want to tell you how we make an eco-friendly product to help our environment for our Indonesia.
Greetings, hello everyone, I'm Shandrina Aliyya M and my friends Adrian Navis S, Aire, Ramadhani, Muhammad Kelvin Ruliandy, Salsabila Prilie P, and Salsabila Putri M. We are from Industrial Engineering Design class, want to present our product Solarscape. Today we want to discuss our product design, component detail, and its function. Our product called Solarscape. It is a solar power water heater that is aligned with SDG7, affordable and clean energy. Its purpose is to reduce the consumption of non-renewable energy. However, from our observation, accessible water heater is usually a non-renewable energy products. Renewable energy water heater is expensive, therefore we targeted our product to be accessible to all kinds of people. This is our product, an eco-friendly, durable, and convenient water heater. The water heater size is 60 cm by 60 cm by 1.3 cm. With its size, this water heater is easy to relocate to customize customer needs of water heater in an instant. It is made from wood and is protected by glass to be able to survive in any condition since mostly it will be located outside. The water heater provides an easy process where copper coil is used to absorb the heat of sun and heat up the water from the connector available to water source. The connector also acts to bring out the hot water using hose, and the design can be wrapped in a compact square, make it easy to install and carry.
This is our product's component. Solarscape consists of three parts, which is the handle, outer body, and inner body. The handle is placed so that it will be easy to carry and grab. The outer body is made from four components. The first one is outer board that is made from wood to protect the material inside and serve as a base. Next, there is a big lumber that is made from wood to frame the outer body. Thirdly, there's a safety glass that is used to protect the copper coil from the outside elements and severe weather. Lastly, there's a hose connector that is used to connect the water heater to the faucet and water heater to the source of water. The inner body also has four components. The first one is inner board that is used to hold the copper coil and zinc plate so that the whole water heater does not break easily when placed standing. Secondly, there is a zinc plate that helps the copper coil to heat up faster. Third, there is a small lumber that is made from wood to support the glass and the interior frame. Lastly, there's a copper coil that is used as a heat exchanger and painted in black so that it will absorb more heat from the sun.
Moving on to the processing step, first the design from the inventor apps that we have made, we move it to a flash disk that is used to transfer files from a laptop to a lab computer with Slicer software. We insert the flash disk into the computer and then we open the Slicer application. Next, we open our product design file by clicking the load button. Then we set the scale of our product by adjusting with the print time. The larger the product size, the longer the printing time will be. To set it, we click the scale button and then we set the scale of the product size. Our group used a scale of 0.075 with a total printing time of 56 minutes. After setting the scale, to ensure that our product can be printed neatly, We first set the position of the product by clicking the rotate button. Here we can adjust the position of the product either in terms of the X, Y, or Z axis. After the scale and position of the product have been set properly, we can save the file by clicking the Save button. The file will be automatically saved on the flash disk, and then the product is ready to print.
Before we start the printing process, we need to turn on the 3D printing machine first. Insert the SD card into the 3D printing machine and insert the filament. Afterwards, we need to set the nozzle and bed temperature of the 3D printing machine. We set the nozzle at 200 degrees Celsius and the bed at 70 degrees Celsius. Once we set the temperature, we need to wait for a while for the heating process so that the machine can be used to print. Once everything is set up properly, the product is ready to be printed. We first click the print button on the machine screen, select our product file, and then click OK. Finally, the 3D printing process begins. During the printing process, we have to make sure that the filament used does not run out and break so that our product can be printed well. Finally, after waiting for 56 minutes, our product was finished printing properly. To lift the product from the machine bed, we need to use the prepared knife because the 3D printing result sticks to the bed carefully. After successfully lifting the 3D printing result, we need to separate our printed product from the printing base. And finally, the 3D printing of Solarscape, a solar-powered water heater by SolarUp, has been successfully printed.
The results of our group's 3D printing had an initial failure, where the copper coil and handle were not printed because the scale was too small. Therefore, we printed our product again by reducing the quality of the print, increasing the layer height from 0.06 to 2.5, because if we increase the scale, the time required exceeds the time available for practicum. In the second 3D printing result, the printing result is still not perfect, where the copper coil is still messy and not completely circular, as well as the handle that has not been printed perfectly. Even so, with the limited time available, the results of the second print are much better than the first.
We are proud to present Solarscape, a solar-powered water heater that is portable and has a compact shape. In the front view, there will be a glass as a protective material underneath. And if we look deeper, in the center of the water heater, there is a circular material, which is a copper coil that functions to flow and heat the water. In addition, as you can see, this copper coil is framed using wooden blocks. And from the right side view, there is a connector tube that will connect the copper coil and the hose that flows the hot water. While on the left side, there is also a tube as a connection between the water source to the copper coil. If we look from the top side, there is a handle that is used to make it easier for users to carry this water heater. And we take a look at the back side of this product, where there is a cover made from wooden block as the base of the copper coil, which looks neat and clean. As well as on the bottom side, we can see a neatly arranged wooden block frame. The overall design of this product is not only minimalist and compact, but also futuristic and can be placed anywhere without reducing its aesthetic value.
In this practicum, our group carried out the 3D printing process to visualize our product design in 3D, which had previously been made in the Inventor application. This process took approximately 2 hours with the lab assistant assisting us throughout the process. The process starts from entering the file and then setting the 3D printing machine to a temperature of 70 degrees Celsius for the printer bed and 200 degrees Celsius for the printer nozzle. After setting up, the printing process begins until the 3D product is finished. Here is the final result of our product with the amount of width, height, and depth is 4.4 centimeters, 4.4 centimeters, and 0.6 centimeters. This is the end of our video. Thank you for watching.